Hi, this is question number 99 on stoichiometry, and shout out to Einstein because the 99th element on the periodic table is actually Einsteinium, and of course is also in honor of Einstein. So yeah, how many formula units of NaCl are produced from the reaction of 25 grams of Na with 2 moles of chlorine gas? Now before we panic, what is formula units? Right? What's formula units of NaCl? So formula units is the same thing as unit of formula. Okay? It's unit of formula, that's formula unit. So yeah. So if I'm talking about formula units of NaCl, it's basically like saying what is the unit of the formula NaCl? NaCl, I'm talking about a unit of NaCl. I can't be thinking about an atom of NaCl because if I were thinking about atom, then it should be an atom of Na or an atom of chlorine, right? But NaCl is a compound, so I'm going to think about it like a molecule. A molecule of NaCl should be the smallest unit of NaCl. Okay, it can be an atom of NaCl. So when you talk about formula units, it is the unit of a formula, and by unit you mean like the smallest quantity. In this case, a molecule. How many formula units of NaCl? How many molecules of NaCl? See that? Good. So now your life is easy. So how many molecules, that's what they're asking us, of NaCl are produced, right? If I asked you how many formula units of chlorine, then you might start thinking about chlorine as chlorine gas, and then it would mean that they're asking you about a molecule. And then sometimes if it's helium, they're talking about how many formula units of helium. Helium would usually be in the the atom form. So if you're talking about formula units, like you're talking about atoms in that case. All right. In this case, this is a molecule produced from the reaction of 25 grams of Na with 2 moles of chlorine. So let's figure out what 25 grams of Na is, right? We divide 25 grams by the molar mass of Na, which I'll just write as 23 here. So that should give us 1.086 in moles. Okay, that's the moles of Na I have here. Now, what's the moles of Cl2? 2 moles of Cl2. Look at the 2 moles you have there, and then divide each of the moles by the corresponding stoichiometric coefficient. That's this number here. This one is for Na, dividing by 2. And this one here is for the Cl2, I'm dividing by 1. Okay, so that's that. And you are going to have new numbers here. For this one is going to be equal to 0.543, I believe. Then this would remain 2. So then you compare 2 and 0.543, and you'll see that 0.543 is smaller, meaning that our sodium is the limiting reagent. So we have to compare sodium with the sodium fluoride and not chlorine with sodium fluoride. So let's use sodium to figure out how much of the sodium chloride will be formed. Yeah, what do we do? 2Na gives us 2NaCl, right? And that would mean that the number of moles 0.543 of Na would also mean that 0.543 of NaCl would be produced. So what do we do next? We can write this as moles, as the moles. But the question is asking that how many molecules of NaCl? We know how many moles of NaCl. We just need to convert that moles to molecules. Okay. According to Avogadro, 1 mole of a substance contains Avogadro's number of molecules. 1 mole of NaCl contains this number in molecules of NaCl. So if I'm dealing with 0.543 moles, 0.543 moles would just mean that I would have 0.543 multiplied by 6.02 times 10 raised to the power 23. If you do that, you're going to have 6.54 times 10 raised to the power 23 molecules. Or will you? No, you will not. And that's because there's a mistake here. This 0.543 that's gotten here was what we did because we wanted to find out the limiting reagent, right? You'll notice that we're not supposed to use this to continue with our proportion, no, but to use the original 1.086 moles we're given. Okay? We're not supposed to use this to proceed here. No, this is wrong. You have to use 1.086, alright? So I'll need to multiply this by 2 to correct that. Okay? So all this extra correction I'm doing, you would not really need to do all this if you are using the correct thing. Okay, so the mistake that I just made right now was to go ahead and use the 0.543, which I got is just a ratio, an arbitrary thing. You have to use what you have, which is 1.086. That's what we're given in moles. Okay. So that's the number of moles that I should have used here, 1.086, and it will also produce 1.086 moles of NaCl. And then you can say that 1.086 moles of NaCl then give you X, and X becomes 1.086 times 10 raised to the power 23 times 6.022. So by the time you do all that, that is when you actually get this. Alright, in molecules. So that's the molecules of NaCl that will be produced, also known as the formula units of NaCl that will be produced. Do you get it? So that's it. So I shall see you on question number 100, because this is 99. Yeah, so let me know. And after stoichiometry, what other topics should we look at? Let me also know. And bye bye.